Hi everyone, my name is Juan Pablo. Welcome again to a new YouTube video. And in this time, I would like to tell you, and the topic I have prepared for today is actually BGP PIC H. Right? Remember that the previous video we were talking about how BGP additional path works, what are the configuration that we need in the route reflector, what are the configuration we need in the P device as well, and what is the purpose of that feature. And also I said that many of us confuse and probably mix additional path with BGP H, right? And we believe that both of them are the same, or sometimes we confuse the term of BGP PIC with additional path and stuff like that. But in reality is that those are kind of different features, but has a same similarity purpose, right? We saw that BGP additional path is basically a feature that allows to provide visibility and improve the host routing in the network, right? So meaning that the P device and also the ASBRs and all the routers in the network needs to forward traffic, they will have all the visibility of all the paths in the network, and this will trigger obviously that they will get to know what is the closest point for reaching out those particular prefix, right? So now those prefixes, as we saw in the previous video, are stored in the BGP table. So each PE router receives from the route vector all the possible paths to reach specific destinations. Now, very aside of that is what is inserted into the RIP or FIP. As you might know, the RIP, FIP, CEF, well, actually RIP is a control plane, CEF and FIP, normally those are common terms, right? And we normally could say, at least in Cisco devices, we can say that CEF and FIP are similar terms. So all of them refers to the forwarding plane. Remember, a box has a control plane, which is responsible for all the memory and all the stuff that normally are in the control plane protocols, like BGP, for example. And then we have the forwarding plane, that actually this is the line card, right? All the components that works in the line card level for the forwarding of the traffic. And these, of course, involve CEF and FIP, forward information base. So those tables can be exchangeable, being mentioned, right? So actually, as you know, the default behavior as a router, whenever I have a prefix and I have multiple paths to reach that particular prefix, my default behavior is to choose the best, right? And I install the best into the forwarding plane, into the line card, right? I install the best prefix and the best destination for every particular prefix. Now, obviously, if I have same cost to reach a particular destination, I can do load balancing, right? Because I have similar cost to reach a particular destination through two paths, right? And BGP has also load balancing mechanism whenever we have a similar cost. You know, we have the keyword maximum path that we will do another video about it, but it's quite common in many routing protocols as well. And also, maybe I will talk about this later, but BGP as well has unequal cost path. So remember that whenever we were learning about IGP protocols, we were looking for HRP, ISIS, OSPF, and from all of them, HRP, if you remember the feasible successor and the successor, HRP has some kind of unequal cost load balancing, right? Well, HRP is not the only protocol that have unequal cost load balancing. BGP as well does it, right? So we have unequal cost. We could have unequal cost to reach a particular destination. And even though that is different than the best path, the cost is different, we could install both of them and do load balancing in BGP, right? There's a keyword that you can extend in the maximum path command to add that unequal cost load balancing as well. But how BGP PIC H enter into this? And I talk about BGP PIC H because there are two types of BGP PIC, right? If we go to the table, we have two types, right, of BGP PIC. BGP PIC H and the core. So core is normally implemented in all the routers now by default. We will talk about core later. I don't want to make so much emphasis on core, but our topic now is BGP PIC H. And BGP PIC H basically is the same what we achieve normally with those fast reroutes or loop-free alternate path in the normal routing protocols. Remember, in ISIS or in OSPF, you know, we have different type of LFA protocols, right? We have loop-free alternate path, we have probably as well remote LFA, right? And TLFA, which is quite common in segment routing, right? Remote LFA, it was quite common in LDP. Now that segment routing came, TLFA with a topology independent way to work and always ensure that there will be a backup path through every specific prefix in the network, then it becomes much more popular, right? But taking the concept, BGP PIC H is equal to those mechanisms that are being used in the routing protocols, IGPs, routing protocols, LFA, remote LFA, TLFA, and all of them has the same purpose, including BGP PIC H in BGP as well, which is to have a backup path, right? That's the ending goal of all of those protocols, TLFA, remote LFA, LFA, BGP PIC H, in the case of BGP, right, is to have a backup path, but not only to have a backup path and find it, but also install that backup path into the FIP or CEF, right? Remember, we mentioned in the beginning, CEF and FIP are the line card level, basically represent the forwarding plane of a box, right? So we want to have into the FIP and CEF and in the forwarding plane a backup path installed. So we, for example, for reaching out prefix X, we don't want to have only the best path, but also we would like to have backup path. Now, how a backup path can help us, right? A backup path it will help in case of failure, right? As any of those backups paths that we have in the routing protocols like LFA, remote LFA, TLFA, if we have a backup path installed into the FIP, right? Whenever the primary path goes down, then immediately the traffic will be switched over to the backup path. So we will not need to look for a backup path or a second best path whenever the best path goes down. So, you know, for finding the best path whenever the previous best path went down, then it takes time for the routing protocol or for BGP to find it out, then install that into the FIP as well. So, you know, we consume those timers and basically we save those timing of looking for a path. You know how BGP converge as well. It's not a very fast convergence protocol. So it takes time to find a path, do the best path selection algorithm, choose the best path, and then install into the FIP. So basically having BGP PIC H feature and having a backup path into the FIP basically save us that time consumption. And you know, convergence, when we talk about convergence as well, it involves many things, right? It's not just that the routing protocol flash out and then try to look for the best path. Convergence starts since we realize that there is a failure in the link level. Routing protocols start to losing the routes and look for another path to reach out those routes, then propagate around the network, then install that best path. Once they find the best path, install that best path into the FIP and CEF. So convergence involves all those pillars that I would like to do a video as well explaining how and what are the components of convergence and also what protocols fit in to achieve the whole convergence in the network, right? Because it has many of those components that we were talking about. But I don't want to explain and expand too much in this video. I just want to show you what is the reason of BGP PIC H, very emphasis in H. Later on, we will go through what is BGP PIC core and then also about this convergence perspective and comment that I was mentioning, right? So then, BGP PIC H, similar to have a backup path installed into the FIP or CEF, which is the forwarding plane of the box. It helps us to save time finding another best path in case our current best path goes down or something happened with that. So we save time basically in looking for and then choosing the best path and then installing into the FIP. So this saves us some time, right? For the traffic to not be interrupted. And you know, especially in BGP, that is a low convergence protocol, the timing is very much appreciated in biggest provider and in any provider as well. Okay, so for the lab, we will jump into the lab. I don't want to go through deep theory about it. It's just a feature, right? I just want to show you how it works. So in the lab, we have the similar case. This is the mock lab one that I'm using for all the videos. So basically ASBR1 has an interface link towards the INET ASBR. Here we have a BRF, right? The BRF is called INET. Over that BRF, we have a BGP session with the INET ASBR router. We receive a default route plus other prefix as well from the INET ASBR. ASBR1 receives those prefixes under the BRF and then propagates those to the route reflector. Then the route reflector propagates to the PE1, which is basically importing those routes into a BRF green that is here. It's called BRF green. And we basically import the default route that ASBR1 is exporting, plus also we import the other prefix, right? So all of them are resides into the BRF green. Here we have BGP additional path, BGP add path, as we configured in the previous video, right? So basically P1 is not only seen as an XHOP for those prefixes ASBR1, but also ASBR2, because ASBR2, I forgot to mention, but also we have a BRF here, INET, and we receive all the prefix as well. And ASBR2 is forwarding the prefix to the router reflector, and the router reflector is obviously having and propagating both paths, ASBR1 and ASBR2 to P1. So P1 see both of them, right? Now, we see both of them into the BGP control plane. BGP control plane is equal to show BGP, VPN before unicast, right? This is a control plane for the AFI VPN before. Now, when we type this command in the P1, we see both of them, ASBR1 and ASBR2, as an XHOP. But if we type show Ceph BRF green, right? Because basically P1 is receiving those prefix, both options, but just importing the best route into the BRF green. It's not importing both of them. It's just importing the best route. So we'll see what routes, what next hops is being chosen from both of them, which one is being imported and which one is being preferred as a best path with this command, show Ceph BRF green. Now, after seeing that, we will enable BGP PIC H into P1 under that BRF, and then we will see that we will not only find the best path, but also will find the backup path, meaning that any of these ASBR will be chosen as the best path, but also there will be a backup path into the FIP or Ceph. Okay, so that's the exercise, and also obviously we will see how to configure as well BGP PIC H. Okay, so let's go through it. Here I see P1, for example, right? So if I type show BGP VPN for unicast, this is a control plane for table for BGP. You see that I see from the route distinguisher 100, which represent basically the INET BRF in the ASBR1 and ASBR2, we see two next hops. And this is because we have BGP additional path configured that we did in this previous video, and you want to see it, you can go through it and look for, right? But if we go through the BRF, show BRF green, and actually we choose, for example, 888, we see that only we prefer the best path, which is 22.22.22. This is ASBR2. Only the best path is being imported into the BRF green and being installed into the FIP or Ceph. And actually I can see that this is the best path, because if I go to the control plane of BGP for that particular prefix, for example, I will see that 22.22 is the best path, right? But I don't want to have only the best path. I want to have a backup path as well. So then I need to go to configure BGP PIC H, address only VPN before, and here, actually, sorry, BRF green, under the BRF, address only VPN for unicast, and here I type additional path, selection, route policy, install. I can do it, right? So I need to create a route policy, install, and here I need to put show set path selection, and here I need to choose I want a backup path installed, only one backup path, and then install. This is a keyword, important keyword. Remember, for additional path, we use advertise in the router reflector, right? Because we want to propagate all the prefix. So we use advertise keyword in the router reflector, but whenever we want to configure BGP PIC H, we need to use install, because we want to install into the FIP and Ceph, okay? And that's it. There are two other keywords as well. One keyword, multipath protect. I'll explain this in another video, but basically is whenever you have many paths to reach one destination and you don't wanna choose some of those paths. But I will explain this in another video. So then I configure this route policy again, and I just would like to install a part of the best path. I would like to install just the first backup path. I can choose how many backup paths I wanna have, but here in this case I will just choose one backup path. Okay, commit. Perfect. If I type now show Ceph BRF green 8888 again, oops, sorry. Then I see that I find two paths into the Ceph or FIP, right? The 22.22.22, and also I find the ASBR1 121 there as well as a backup, right? So I find here both paths, the best path and the backup path, and the backup path will be used whenever the best path is down, right? And it will allow us to save time during the convergence, right? That's what BGP PIC H actually does, and it has some drawbacks that I would like to share as well, because obviously Ceph and FIP it consumes the line card, right? The line card of the box. So if you have a modular box, there is many line cards there, or if you have a fixed box, there are ports as well. But anyways, there is a line card there included, right? So if as many of prefixes you have in the line card, it consumes memory of the line card, right? And obviously, depending on the vendor, you'll have some buffer, how many routes and prefix you can have into the FIP and CEF. So that's why it's very, very important to look into this feature, especially if you are receiving the wall internet routing table and if you want to have a backup path for the wall internet routing table. So it's very, very good to take a look into what's the memory buffer for the boxes of the vendors, and also how many routes in BGP you want to have a backup path, and more or less do those calculations and comparison, and for not basically the box to get exhausted and to be filled out with all those buffers of the routes into that. BGP PIC Edge is a very good feature. It improves the convergence for BGP, but also this is the topic that you must look for if this fits in your network as well. So it's sometimes very good to use it. Sometimes you must use it a bit limited as well. That was BGP PIC Edge. I hope that you have enjoyed the video, and see you next time explaining about BGP Core and also the multipath keyword. And also soon I will do a lab showing the ostinato, which is very, very, very good tool if you want to test some traffic around the network using EVNG. Okay, so thank you very much for watching, and see you in the next video. Bye.